Okay, so welcome to this course. This course is the quantitative research method, and today is week 11. Today's topic we will cover the simple linear regression. I'm instructor追踪崑from the Kunshan University. Okay, so let's go to our topic. And today's topic we will cover the simple linear regression model and the least square method and the coefficient of determination and the model assumption and testing for significance and using the estimate regression equation for estimation and prediction. Okay, so let's talk about the definition of simple linear regression. Okay, so the manager decisions often are based on the relationship between two or more variables, and the regression analysis can be used to develop an equation show how the variables are related, and the variable being predicted is called the dependent variable and is denoted by y. Okay, dependent variable we denote by y, and the variable being used to predict the value of the dependent variable are called the independent variable, and we are denoted by x. Okay, so the easy way is if x then y. So we can call the change of x, maybe then the y will be changed. So this is we want to find a relationship. So we do the linear regression. Okay, let's go to the next slide. Simple linear regression involves one independent variable and one dependent variable. So we call it simple. And we will talk about the multiple linear regression. Multiple is more than one independent variable, and sometimes with more than one dependent variable. Okay, so simple is just one independent variable and one dependent variable, and the relationship between the two variables is approximate by a straight line. So you can see is the negative relationship, positive, or maybe no relationship. This is a straight line. Okay, regression analysis involves two or more independent variables. It's called multiple regression. Okay, so this we will talk about the simple linear regression model. Okay, the equation that describes how y is related to x, and an error term is called the regression model. So you can see the simple linear regression model is y equal beta 0 plus beta 1x plus spin. Okay, called error term. Okay, so where beta 0 and beta 1 are called a parameter model. Spin is the random variable called the error term. Okay, so this is the linear regression, simple linear regression. So we were just one independent variable and one dependent variable. So if it's a multiple, you can see the formula. You can see that maybe have x1, x2, x3, and the y maybe y1, y2, y3. This is the multiple linear regression. Okay, so this is the simple linear regression equation. You can see the E is expected value. Okay, so we can see the beta 0 plus beta 1x. So you can see this is the same. We don't have the error term in here. Okay, so graph of regression equation is a straight line, and the beta 0 is the y-intercept of the regression line, and the beta 1 is slope of the regression line. Okay, beta 1 is slope, and the E y is the expected value of y for a given x value. Okay, so this is the graph for the positive. You see the slope. This is the this is a positive slope is positive, and the beta little, this is the intercept. Okay, so you can see the vertical is x, horizontal is the horizontal is the x, and the vertical is e. This is the y. Okay, so this is the slope is negative. So this is the say is the x and y. They have the negative relationship, and this is the no relationship because the slope is 0. Regression line. Okay, so this is the estimate simple linear regression equation. Okay, so this is the process. So we can see the regression model. This is the y is equal beta 0 plus beta 1x plus epsilon, and the regression equation is this one, and the unknown parameter this beta 0, beta 1, and we collect the data, sample data. We have the one independent variable, and the y, this is the dependent variable. So we collect several data, and we put in the regression equation, and we can find the beta 0, beta 1. Okay, and this is the least square method. Okay, so this is the y, and the y, this is the estimate value of dependent variable. Okay, and the y1 is up there, the value, and this is the slope for the estimate regression equation. In the formula, you just need to know, because we in the SPSS you can calculate this number. Okay, so now you just need to know the formula, and the y is intercept. Okay, so in here we will do the practice. The auto predictor have a special week-long sale, and the advertising campaign run one or more television commercials during the weekend preceding the sale. Data from the sample of 5 previous sales are shown on the next slide. Okay, so the is the one independent variable, number of TV ads, and the number of car sales. Okay, so maybe we can put in this example we can do in SPSS. So first we can open the SPSS program. So this program is from IBM SPSS Statistic version 25, and this software is the school already buy this license. So this is the legal use for this course. So we can, first one is number of TV ad. So we can, in the variable view, the first one we can call the number number 8. Okay, so this is the integer, so we can type the number of TV ads. Okay, and the second one, number of car So this is the same, the integer. Okay, so we can number of car sold. So this is the dependent variable. So now we have the two variables. Okay, so we can type the data into the data set 1 and the 14 and the 3 and 24 and the 2 and 18. There is 1 and 17 and 3 and 27. So we have the 5 record. Okay. So now we can calculate. So we just check any correct. Okay. It's okay. So this is a simple regression analysis. So we can go to the analyze, and you can see the regression, and we choose the second one, linear. Okay, and in this box we need to choose which is the dependent variable. Independent is the x, dependent is y, because independent change the independent variable will change the dependent variable if they have the relationship. So independent variable is the number of TBA, and the dependent variable is the number of cars sold. Okay, so it's okay. So measure, we don't need, we didn't change, also no problem. And you can see the statistic, and maybe we can choose the R square change, descriptive. Okay, and sometimes we do Watson test. Okay, it's okay. So we can see the output. Okay, you can see in the first table we can see the dependent variable is the number of cars sold, and we independent just one, number of TBAs. And you can see the second table, this R square is the 0.877. What's the R square? The R square mean is the independent variable. The number of cars sold will explained by the number of TBAs is 87.7%. Okay, so it's very high. And the regression, you can see the significant level is 0.01. This is the larger than the small than the 0.05. So this is the significant. Okay, and this is the you can see the linear regression model. This number of TBA, the standard coefficient, the beta, this is the 0.937, and you can see the constant. Constant is the 10. Okay, so this is the significant. Okay, if the p-value is the less than the 0.05. Okay, so now we go to the slide, so you can check. So you can see the regression model. You can see this is the y is the 5x plus 10 is unstandardized. Also, you can write down in the y equal 0.937x this and the plus arrow turn. Okay, this is this. Okay, so maybe we want to draw the graph, so you can go to the graph and the attributor, and we can choose the line. Okay, so the x-axis is the horizontal. This is the number of TBH, and the vertical is number of cars sold, and it's okay. So we can see the graph. Okay. So this is the, you see the positive, you see the slope. This is the positive, and then maybe we can add the linear formula, regression formula. You can put in the element, show the data label. No, this the we didn't need this. So you can check the option. Okay, size. Okay, this. Variable, okay, is the size category variable, like option. Oh, show the, see the window, add the title. Okay. Okay, so this is the chart, we already found it. Okay. So we can check this is the same. Okay. Okay. So the relationship. Now we talk about the coefficient of determination. This is the, we can call the SST is the total sum of square is equal to the SSR sum of square due to regression, and the plus SSE sum of square due to error. Okay. And the coefficient determination, this is r squared equal sum of square due to regression is divided by total sum of square. So you can see the r squared is the sum of square due to regression, total sum of square. So you can see the r squared 0.8772. So we can check the output. So you can see the r squared is 0.877. So the formula is the compound tier. Okay, the rate is very strong, 87.72% of the variability in the number of car sold can be explained by the linear relation between the number of TV ads and the number of cars sold. Okay, so also in the Excel you can use you can show the picture in the Excel. Okay, so let's go to the next, and the correlation coefficient. So we can see they have the correlation, and so this is the correlation coefficient. You can see in here we can check the relationship. Okay, so let's go to the analyze, and we can get the correlation, this data in a correlate, and because we just have the two variable, is the number of cars sold and the number of ads varied. So we choose the two variable, and maybe Pearson. Okay, so we can check the correlation is the 0.937, and the relation is significant. Okay, so you can check the slide and check our output. Okay, so you can see we got the same 0.937. Okay, so this is a positive. We didn't see the negative sign, which this is the positive. So the mean is these two variable relationship is the positive. They have positive relationship. Okay. So the assumption about the error term. The error S-bin is the random variable with the mean of 0. The variance of S-bin denoted by theta square is the same for the all value of the independent variable, and the value of the S-bin are independent. The error S-bin is normally distributed random variable. Okay, so in the test for significance, we can test either two tests, the t-test and the f-test. So the test significant regression rate, we can conduct hypothesis test to determine where the value of beta 1 is 0. Okay, and both t-test and f-test require an estimate of the theta square, the variance of the S-bin in the regression model. So in the output, we can see you can see the f value. This is the f test. Okay, and you can see the t test, t value. This is the t test, and also is the significant. Okay. Okay, so this is the hypothesis, the t-test. The hypothesis we just talked about. This is the last class, and the hypothesis we have the two condition. One is HDO, this is the new hypothesis, and HA, this alternative hypothesis. And the HDO is beta 1 is 0, and the beta 1 is not equal 0, and the test statistic is T, and this we already talked about in this class. And the rejection rule, rejected 0, p-value is the less than the alpha. So the t-test, okay. And the confidence interval for the beta 1, we can use the 95% confidence interval for beta 1 to test hypothesis just used in the t-test. H0 is rejected if the hypothesis value beta 1 is not included in the confidence interval for the beta 1. Okay. Okay, so some caution about the interpretation of significant test. Reject H0 beta 1 is equal 0. Conclude that the relationship between S and Y is significant. Okay, doesn't enable to conclude the cause and the effect relation is present between X and Y, because the beta 1, you can see if the beta 1 is 0. So you can see the formula. Go to the beta 1. The regression. So beta 1 is 0. So we don't have the independent variable. We change it didn't influence the dependent variable. Okay, so this means in here. So reject beta 1 is not equal 0 just because we are able to reject. The significant doesn't enable to conclude that there is a linear relation between X and Y. So understand linear regression with one predictor and how we assess the fit of regression model. And this is we can use in SPSS, and how to use the regression as we already run the example. So the regression, what is the regression? So this is the way predict the value of one variable from another. So we already talked about this. Okay, so this is the B1, the regression coefficient for the predictor. Okay, and the B0, this is the intercept, and the B1, this is the slope of regression line. And you can see this is a positive, and the green line, this is negative, because the slope of this line is the negative. Okay, and ANOVA, this we test the model. And this is the F value, F test R squared, the proportion of variance come for by the regression model, and the Pearson correlation coefficient squared. Okay. Okay, now we do the practice. It's one example. A record company boss was interested in predict an album sale from Untitled data. This is a 200 different album release outcome variable. The sales, CD and the download in the week after release. And the predict variable, the amount of spent promote the album before release. Okay, so we can find the data album sale.sab, this file. Okay, before we do this practice, in the regression this section, we have the this is the simple regression analysis. We have the one independent variable. This is obtaining budget, and the one dependent variable, and this is album sale. So in here we can see this is the data and the outcome. This is the sales and the predict variable. So amount of the spending album release. Okay, this is we see the obtaining budget. Okay, so we can check the file, and the file is already give you in the week 11 folder. So let's go through the SPSS. So you can see this formula. This is we can see this Y. This means is will be the album sales, and the S1 will be the obtaining budget. So the B0 is the intercept, and the B1 we can call the regression coefficient, and also we can call the slope or regression line. And we can get this kind of the chart. Okay, so how good is the model? The grid is only a model based on the data, and the model might not reflect reality. We need some way to test how well the model fit observed data. So you can see we have the several SS. This is the total variety between score and the mean. SSR, ratio error variety between the regression model and the actual data. And the SSM is the model variety, difference in the variety between the model and the mean. So we can see this one. SST, the total variance in the data, and the SSM, improvement due to the model, and SSR, error in model. So you can see in here. This is the sum of square, and the second one SSR, and the total is SST, and the mean square. This is the and the MSR, this one. Okay, so you can see the F value and the R square, so we can calculate. Okay, so let's go to this album sale list file. So we go to the week 11 folder. We can find the album sale list SPSS file. So we open the program. Okay, so you can see in the data, in this data we have the 4 variable, and in this example we just need to use the 2 variable, obtaining budget and the album sales. Okay, and the data view, we have the 200, and see we have the 200 samples. Okay, so let's go to we do the simple regression analysis, because we just have one independent variable of tiling budget and one dependent variable of airborne sales. So go to the analyze and the regression, and we choose the second one, linear. Okay, so the first one is you see the box. First one is the dependent, so dependent variable will be airborne sales, and the independent is the tiling budget. Okay. And the first one, we choose in the right side, you can see the box. Choose the statistic, and in the box we can see the regression coefficient. The first one is estimate, and we see the second one, confidence intervals. We can choose the confidence interval is the 95%, and we choose the model fit. And this option is vital, and so is selected by the default. It provides not only a statistic test of the model ability to predict the outcome of variable, but also the value of R, the corresponding R square, and the adjust R square. And also we check the R square change. The option displays the change in R square result from the inclusion of new predictor, and the measure is useful way to assess the contribution of the new predictor to explain variance in the outcome. And the descriptives. This option displays a table of the mean, standard deviation, and the number of operations of all of the variables included in the analysis. The next one is part and the partial correlation. This option produces the zero order correlation. It's the same the Pearson correlation between each predictor and the outcome variable. Okay. And the next one is the collinearity diagnostic. The option is for obtaining collinearity statistics such as the VIF tolerance, the eigenvalue of the scale on central cross product matrix, condition index, and the variance of property. Okay, we will talk about in a later class. In the Dubin-Watterson, this option produces the Dubin-Watterson test statistic, which tests the assumption of the independent errors. Okay, so we continue, and the second one, plot. This is the output will show the graph. So this is the first one is dependent. Okay, so we choose the first one. Y is the DRESID. This means this value is the standardized difference between the observed data and the value that the model predicts. And the X, we choose the DPRED. Okay. The standard predict value of the dependent variable based on the model. These values are standardized form of the value predicted by the model. Okay. and we show the histogram and the normal probability plot and produce all partial plot and continue. And the save, you can see is a lot of the function you can choose. First one, the pretty very unstandardized, standardized, and adjust, and the standard, and we can see the SE, mean prediction, okay, and then you can select, okay, and the ratio is the standardized. So delete, student I delete. And the continue. In the option, you can choose like the stepping method criteria. Its entity is 0.05 and remove is the 0.1 and the include constant in equation. And the continue. Okay. So this is the, we can click OK. So you can see the first table. This is a descriptive statistic. So you can see the mean, the mean value, the upon sale. This is the 193.2, and the planning budget is the 314. Okay, and the standard deviation and the sample is the 200. And the second one, this is the correlation. So you can see they have the positive. So you can see the positive correlations. So you can see the significant. This is the significant. So these two variables, upon sale and the time budget, these two variables, they have the positive relationship. And the next table, this is to show the, you put the which is the dependent variable, which is the independent. So dependent variable is the upon sale, and the independent variable is the planning budget. And another table, this is the R. You can see the R square is the 33.5%. You can see the, you can tell the planning budget upon sale is explained by the time budget is 33.5%. Okay. So next you see the F value, F test is the significant, and the next is the coefficient. So you can see this, the T test is the significant, because you see the significant, the value, the P value is the less than the 0.01. So this is the regression formula will be 0.096 multiplied by planning budget plus 134.14. This is the formula. Okay, so you can see the chart. This is a regression, and this is the scatter plot. Okay. Okay, so let's go to see our slide. Okay, our slide. slide week 11. So you can see the slide. The procedure we already used, you can see it's the same. We can cut the R square. Then the number we got the same is significant, and this is F test, and this is the center coefficient. You can see this formula is the same. This is a linear regression model. Open cell equal is 134.14 plus 0.096 multiplied by uptime budget. So if you have time budget is 100, you can put in this formula and get the open sales. Okay, so this is about the today course. Is there any question? You're welcome to ask me in the class or in the online form. Okay, so see you next week.